Sir, why the current will change, sir? As it is connected in series, no, sir. Not only the voltage will get changed now.
Aditya, you can see from the characteristic only voltage will change. I have changed the current.
I mean, it's normal. Like when we
See, I agree, but you have to look at the screen. Whether I have changed the current?
No.
So I have changed the voltage only. See in y-axis. So voltage point is changed, but current point is remain at 0.8. Have to look at the screen. I have not changed the current. Agree or not?
Agree.
Yeah. Now let's go to the parallel connections. Let's go to the parallel connections. So in parallel connection, how do we draw this IPV characteristic? How do we draw this characteristic? So in parallel connections, what I have
voltage will be same, sir.
Yes, voltage will remain same.
Current will be added.
Suppose we have 0.8 ampere current for one and 0.5 volt voltage. So if I'm connecting two panels or two module or two cells, whatever you can say, right? Whatever you can consider in parallel this way. Okay, so the rating of this is increased from 0.8 to now the magnitude of current. If you take out here the IPV, that would be 0.8 plus 0.8 because one cell is producing 0.8 and another cell is also producing 0.8. So total current that would be 1.6 ampere. However, if you find out the voltage would remain same, that is 0.5. The characteristic this the characteristic will look like we have I in amps. Characteristic that 0.8 ampere. So and the voltage that is 0.5 volt. We have voltage here in volt. So initial characteristic that will be like this. But the characteristic for second figure, right? The characteristic is going to change at the current side. So the current characteristic will be, but it is coming down at the same. The current toward the y-axis, or we can say we are increasing the characteristic, the magnitude of current in y. Only two panel in series. Now let's few panels I have added in series as well as in parallel. Suppose what I have done, and another set of two panels or two cells which are connected in parallel. Means these two panels, first two panels they are connected in series, second two panel they are also connected in series, but the combination of these panels they are connected in parallel. Can you tell me the characteristic or tell me the voltage and current? Panel has the voltage of 0.5, it also has 0.5, it has 0.5, it has 0.5. First set of panel how much?
2 ampere.
Why 2 ampere?
0.5, 0.3.
Okay, this is the voltage. This is
Okay,
not.
okay.
1.6.
Voltage will be 1 volt.
Yes, so voltage will be 1 volt because they are connected in series.
And now current will be 1.6.
1.6. Why? Though we have connected two panels.
Yes.
It will increase? No, it will not increase.
No, it will be 1.6.
Yes. Whether you have connected 3, 4, 5, 2 or 5, 6 panel in series, there is no increase in the current. So it will produce 0.8 ampere only. It is also producing 0.8 ampere. So the total current that will be supplied to the load, that is 1.6 ampere. Now you can draw the PV characteristic. So initial characteristic, it was only 0.8 for one panel and 0.5. Now we will shift the characteristic in x-axis as well as in y-axis. It doesn't mean it will be shifted only in x-axis or y-axis. In both the axes, this current is going to shift. So suppose this is 1.6 ampere and this is 1 volt. So my characteristic is going to shift in this way. Initially we have this characteristic, but now it has been shifted in x-axis as well as in y-axis. So this is the characteristic for this panel. Any confusion in this? How do we draw the characteristic for these panels?
Repeat once again, please.
Yeah. Now, how do we get this characteristic? How do we get this characteristic? Hmm? Semiconductor material that we are using for this. Correct? Semiconductor material that people are utilizing for having this.
Yes.
So, how do we derive these characteristics? My question is, how do we get these characteristics? Any idea?
No idea, sir.
And how do we, what is the equivalent circuit?
I'm not in electrical based
Hmm?
department, so you have please take teach me,
No,
sir.
no, my question is, how do you get this equivalent circuit for PV module?
No idea, sir. Please tell me.
Yeah, sure, I'll tell you, don't worry. Anyone else who knows how do we perform this?
I didn't understand that. Say it again, sir. Like,
What is the equivalent circuit? Equivalent circuit of this PV module?
right now the
Yeah,
okay.
yeah. Go ahead.
No idea, sir. Like, you go ahead, sir.
Yeah, okay. Anyone else? No idea, let me tell you. So in case of this, the circuit which we are drawing here, that is only this one, right? Now, this is coming, only semiconductor material people are using, monocrystalline, polycrystalline, some other material people are using for this PV panel. But inside this, if I consider a simple semiconductor device, that is diode, right? So if I'm considering a device that is diode, and this diode, actually this is a dissipating device. This cannot be a source, right? So this diode may have certainly some anode terminal and some cathode terminal. Right? So this device is trying to, I mean, if suppose the conduction is happening, so it will try to take current and it will make a closed path. So some voltage like VAK that will appear across this, and power flow will be from external circuit toward this. Right? Suppose we have some external circuit which is connected here. External source we can say. External source we can connect. Now the question is, let's suppose battery is connected as external source. So it will try to turn on this device, and this device is acting as a sink, not source. But this PV panel, if you look into it, it is acting as a source. Now my question is, how we can make this combination as a source, so that the combination of source current voltage or some other source along with this diode, it can initiate the energy or it can generate the energy instead of dissipation of the energy. Because diode, what the diode will do, it will dissipate the power, it will not generate the power. Are you agree with me? I mean, diode dissipate the power, it cannot generate. But here, semiconductor material which are there at the solar side, they are generating the power. So what are the kind of circuit which we are involving here? But if you are considering only diode, this will act as a sink circuit, not a power generating circuit. So there is a requirement of extra component in it, right? So diode, it is acting as a sink, right? it is not, cannot generate the power. It cannot generate the power. So we need
So sink means
it can take the power.
okay.
Yeah. So we need some extra component. Extra component make it PV cell. Some extra component is required so that we can make the PV cell. Now, if you consider only diode, what is the characteristic of a diode? If you consider only this, so characteristic of a diode is like this. We have I and we have V. So IV characteristic, it will be turned on at 0.7 volt, right? Yes. So it will start in conduction immediately after this. Now, our interest is to make this device as a source device instead of sink. How diode become a PV cell. So as you can see, this photodiodes, the lights that is falling or sunlight which is falling on these diodes. So one extra source that we are creating here due to these photons. So in case of PV cell, we have one source which is acting as a photocurrent, right? And along with this photocurrent, we are connecting this semiconductor device. This is the actual equivalent circuit of this PV panel. So this IP, which is higher than this ID, which is going in the diode for conduction. So net current, instead of taking current, what will be the net current? That would be, because IP is larger than this ID. Correct? So net current will be supplied, or the net IPV current that will be supplied to the load, and power flow will take place. Instead of power flow to the diode, now this combination, the source and the diode, it starts generating energy to the load, or they are supplying the power to the load. Now this becomes as a source. This was as a sink. The direction of current is also changed. Initially the direction of current was this, right? Now the direction of current is changed to this. If the direction of current is changed, my characteristic will also be flipped. So if I have initial characteristic in this manner, my characteristic will be flipping in this way, right? This is I and this is V. So that's why.
More simple term. I didn't understand here. Like, can you explain in more simple term? Like, you explain in more simple term. Like, I'm finding it a little hard. Like to understand that.
Yeah. So what I'm telling you, if you are having a single diode as a semiconductor material, so diode it is acting as a source, right? It is dissipating some energy, and it is coming. The energy is coming to this diode, and it is making closed path. But solar cell, it is acting as a source. It is not acting as a sink. Sink means it draws the power. Source means it is supplying the power. Now the combination. So alone diode cannot supply the current. We need some extra source. So that's why you can see we don't have only semiconductor material. We are also having source of light on it. So source of light that we are representing here as a photocurrent. So the combination of photocurrent plus diode that is supplying power to the load. Are you getting it? So photocurrent, it is the intensity. This IP will depend on the intensity of light. Suppose intensity of light is low, so IP will be less. If photocurrent or the intensity of light is good, then photocurrent will supply higher magnitude of current. But this diode will, it is a semiconductor material. It will dissipate the energy, but the value of IP is far larger than this ID. It is greater than this ID. So IP is greater than the ID. That's why the net current that is supplied to the load.
Shalendra sir, I have a question.
Yes, sir.
Yes, one by one I'll take the question because this topic is very interesting.
What is photocurrent over here? Like, what does the photocurrent do?
Photocurrent, that is the sunlight which is falling on the plate.
So sir, I have a question.
Yeah.
This photon which is coming from the sun rays, it is falling on some kind of a substance. Might be a semiconductor, or might be some kind of sandwich something substance, which might be emitting those electrons to drift from this IP to ID and as well as to the source.
Correct.
So which substance is this, sir, which is showing such a characteristics?
Which substance means?
Means sir,
there is some metallic plate, right? And metallic plate, we have some, we can say some depletion region will form. So holes and electrons are there, correct? And there is some free electrons. So due to combination of holes and electrons, a layer will be developed. And that layer, that is known as depletion region. So there are.
What is that term for using battery?
Sir, this photon particle, it is directly falling into those diodes.
See, diodes, I have represented it as a diode, but initially what you will find out, we have this kind of plate, right? We have this kind of plate. So these photons, I have represented in an equivalent circuit, right, to understand, right? And this intensity of light is just falling on this plate. So this semiconductor material I have represented as a diode, nothing else. See, because here the material which I am showing, it is having an N-type material as well as P-type material. Are you able to follow? We have glass on the top of this N and P type of material, so they will have some kind of doping, whether it is a N layer or P layer doping, and due to recombination of these holes and electrons, they will form the depletion region, and those electrons which are free, they will go to the they will cross this depletion region, and the current will start flowing. Some electrons will be there which is going beyond this, and then this photocurrent starts flowing from this. So I'm not representing only diode here, the combination of this circuit, combination of this source, that is the net.
What an external source here? Is it a battery?
Yes, so initially we have shown, here we have connected a battery. But after this, you can also connect a battery. Yes.
Okay.
Yeah, you can connect one resistance. But
That is the source.
here,
That is
yes,
the
external.
source.
Yes.
Okay, sir.
Yeah.
Sir, I have a question.
Yeah.
How many layers in PV?
Sorry.
How many layers in PV panel?
How many layers means we have one metallic layer up top of the. Basically, we have 4 layers. If you ask to me, we have metallic strip, right, in the top of this panel. Then there will be a glass, right, on the surface, and then we have N type of material and then P type of material. There are 3, 4.
N-type means?
N-type semiconductor, we have this electron and holes, no?
Okay.
Yeah. So that
And P-type means?
yes, P-type, N-type, and P-type, we have electrons and holes.
N-type and P-type is also semiconductors.
Yes, that is the part of semiconductor.
Okay.
Yeah.
Sir, can we extend the below circuit again? Current flow.
Which circuit?
Below circuit.
Yeah. So 2 things I have told you. Yes. So 2 things I have told you. Let me complete one. Let me answer one question, and I'll take another one. So we have taken this IP here, that is coming, or that is due to the intensity of light, and another device which you have considered a diode, which is due to the semiconductor material. Now, this IP, it is larger than this ID, which is dissipated by this diode, because diode has very less losses, right? Semiconductor losses when we are forming the depletion region, holes and other form. So, but this diode, it cannot act as a source. It will always acting as a sink, because semiconductor will offer some resistance. It is not offering some source like battery or current source. But a combination of this diode along with the photocurrent, it is acting as a source. Right? So intensity of light, which is falling on this semiconductor material, the combination of these two will make a source of this panel. This is the overall idea. So if you flip the current, because now we are going to supply the current, so diode characteristic will be flipped in this way. Right? Once the diode characteristic is flipped, instead of supplying power, you will generate the power. Correct? Now let's see the total equivalent circuit. Right? Total equivalent circuit, we got this photocurrent, and then we got one diode. After this diode, we have to add some impurity of this material. So we are adding these panels in series and parallel. So we will use one resistance, impurity of the material in parallel along with this, and one resistance which we will add in the series of this RS. Correct? And then the total power that we are going to supply. So let's suppose this is VAKNO2 cathode. This symbol people are representing in this way. Whether they are representing this way, NO2 cathode, VAK voltage, or any voltage, VPV or whatever you can say. It is, people are also presenting as a VPV. Some IPV current is flowing here and this. And the characteristic which I have already shown, the characteristic they are presenting in this way. I versus V characteristic.
Yes, sir, I know. Like if I use a diode, there will be a 0.7 voltage drop. Was that correct or not, sir?
Yes, you are very much correct. Yes, there will be a drop of 0.7 volt. I have not, ignored it. We have considered. That's why I have told you some current is flowing through this diode. There will be some drop, definitely.
But why did I add the diode in a series, sir? No, I mean, why did I add the diode in a parallel actually?
You have to add this diode. Otherwise, how do you get the photocurrent? If you add in this diode in the series, right? Then how do you pass the current? That is my question.
Like I'm getting confused. Like here, diode linking with the photocurrent. I'm getting too much confused here.
So see, if you add diode in the series with this source, the whole current, whole photocurrent will pass through this diode. So I square R losses will be more. Yes, you are right. Sir, you have added. Can we add this diode in the series? Yes, we can add. But you will find out the whole current IP will pass through this. So I square R losses, they are depending on the magnitude of current, right? So only fraction of current is.
So the ampere will be more. That is the reason we added the diode in a parallel. Is that correct, sir?
Yes. So that we can ignore or reduce the losses in this.
Okay.
Yeah.
But instead of using a diode over here, like we straight away we can use the resistance. As you can see over the diagram, resistance has been used. Like why do you need the diode over here, sir?
Because it is semiconductor material. It will have some anode and cathode, photodiode. How resistance will generate the power?
No, resistance will as I know, resistance I use for like it will it creates like resistance actually we use for.
Let me tell you, this resistance will not have any depletion region where the electrons can cross this depletion region and they can make a combination and current can start flowing. It is happening only in semiconductor material. So semiconductor material will have how many junctions? P and N, right? So that's why we have represented this circuit or this semiconductor as this PV as a semiconductor material, and in results we represented it as a diode. The LEDs you might have seen, LEDs they are blinking when lights are falling or you are supplying some voltage to it. Right? There are also people are presenting with this photodiodes or some diodes which is blinking or lightning. So the equivalent circuit we have seen. Now there are certain component or certain signals which are representing. Right? So IPV, if I wanted to write, suppose this is the I photo current, IT is going here, and IPV current that is coming. So how do I write IPV? That is IP photo current minus the total current which is going to the diode. Right? So losses in the diode we have ignored here, and that way we got the IPV. Now if I am representing PPV, PPV is nothing but the voltage. Suppose this is VPV, right? So VPV into whatever the current that is flowing here, IPV. Sorry, I'm not representing this current here. I'm representing the current at the output side. So VPV into IPV. Now, one thing can you tell me? If suppose I'm saying I have 10 kilowatt solar power plant. If I'm saying I have installed a 10 kilowatt solar power plant, right? Or solar for this charging station. To develop the charging station or charging infrastructure, I have considered 10 kilowatt PV panel. Now, my question is, can we get this 10 kilowatt power from this panel or this power plant for charging purpose?
It depends upon the sunlight, sir.
Sunlight. Suppose the intensity of light is 100%, or we are operating at 1000 watt per meter square. That is the maximum intensity of light. 1000 watt per meter square. That is according to standard temperature condition. If I am not STC, people used to call at STC. At STC, the insolation is 1000 watt per meter square.
But still, there will be some losses, sir. You won't get 100%, sir.
What kind of losses that are occurring?
Normally, like I believe, like 10 to 20% losses would be there. Normally, we take those actually. 10 to 20% losses we carry with it.
Take 20% losses. Okay. So suppose those losses we have considered, then we will get this. Suppose 20% losses we have considered, and after considering 20%, the power was 8 kilowatt. Now we will get 8 kilowatt power from this installed capacity.
Yes, sir, yes, we can get depend and with the same at the same time with the intensity of the sunlight also.
Intensity of light, I told you, we have rated intensity of light like STC. We are operating at STC.
Then we may get 8 kilowatt.
Then we will
There
get
will be also losses in the internal circuit, like those diode and resistance which are already
that we have included inside this 20%. So in case of whenever you are talking about, like we have installed a 10 kilowatt PV plant in a charging station, never it will supply 10 kilowatt. So this 10 kilowatt, that is known as installed capacity. Installed capacity. Installed capacity means according to this 10 kilowatt, we are going for installation.
Sir, hello, sir.
Yes.
Sir, hello. Sir,
Yes, please go ahead.
I wanted to know, sir. I will take 170 watt panel. How the semiconductor will provide voltage and current to the PV from the PV.
170 watt panel you have taken.
Yes, sir. how the semiconductor, it is also a semiconductor device. How?
No, but see, yes, but the question is, you have power rating, but at least we should know voltage or current. Without knowing the voltage and current of this panel, we will not know the other parameter.
This is not my question, sir. My question is that it is a panel, suppose a 70 watt panel. How voltage and current is coming from the sunlight? When sunlight will come, how voltage and current will provide to the MPPT solar, MPPT charger? Let me explain this, sir.
So whenever you have intensity of light, what is happening, right? It is a simple electrical device that converts this solar energy or light energy, right?
How electron and the hole and the deflection layer is working in the panel?
Whenever
Can you explain?
when the lights are falling in the semiconductor material, right? So, surface of semiconductor material, then what it will do? It will emit the electrons. Due to photoelectric effect, there is emission of electrons. In practical solar cell, if you talk about the practical solar cell,